Hello everybody, my name is Devendran analaki Saegaran. My card matrix number is B1324100052 and today I will be presenting about Lab 6 problem solving using GPA calculator. I hope you enjoy this presentation. This is for my lab test for the subject Bmkt 1723 computer programming. Firstly, let's talk about the learning outcomes that we receive from this lab. Obviously, the main learning outcome that we received from this lab were to practice input handling. Other than that, we also learned array manipulation and to build a complete GPA calculator program in C++. Now that we are all caught up, let's get into the questions. Let's start with the first question. The first question is, we are asked about the role of cin-ignore and what happens if we remove cin-ignore. Without it, the new line left in the input buffer after cin credits will be consumed by getLine, causing the subject names to appear empty. That's why cin-ignore is necessary before using getLine. Now let's get into question 2. For question 2a, we are going to code and display stored inputs. As you can see in the slide, I have inputted the coding that we used for this GPA calculator and it's run so far. Now let's talk about question 2b. The question is, why do we use size as a constant instead of directly using 2 in our array declarations? Let me answer. We use size as a constant to make the program more flexible and maintainable. For question 2c, the question asks, what would happen if we try to access subject 2 in our programs? Well, accessing subject 2 when size is 2 causes an out of bounds error. Next, for question 2d, the question is, how would you modify the input validation to ensure the subject names are not empty? For that, we have added a validation to ensure the subject names are not empty by using a do-while loop. As you can see here, I have added the coding for the do-while loop. That was fantastic. Now, let's get into question 3. As for question 3a, we are asked for a code to display grades and points. And for question 3b, we are asked for a completed grade conversion loop. So, question 3 is focused on converting scores into grades and points. We display them using a loop and completed the grade conversion logic for all ranges based on UTEM's GPA scale. Here, I have added both the coding for question 3a and question 3b. Now, let's move into question 4. Question 4a asks, why do we need to separate arrays for grades and points? Separate arrays for grades and points are given so that grades store letters such as A, A-, B+, while points store numeric values such as 4.0, 3.9 and 3.3. This separation allows for easier GPA calculations. Now, for question 4b, we are asked how do we handle invalid scores that are outside of 0 and 100. This is done by adding a code for an invalid value. It is shown in this slide right here. Now, let's move to question 4c. We are asked to calculate the expected GPA for subject 1, 3 credits, score 85A, and subject 2, 2 credits, score 72B+. Here is a little calculation of that, and we get a GPA of 3.72 following the formula that we normally use. Next, for question 4d, we are asked, add an error checking to prevent division by 0 in GPA calculation if the total credits are 0. This is done by adding a if-else code to prevent dividing by 0. Next, let's go to question 5. Question 5 is quite a simple one. We are asked to modify the output to ensure A. The subject names are left aligned, B. The numerical values are right aligned, and C. All columns line up perfectly. This is done very easy. We use set W to align columns left for subject names, right for numerical values. This ensures the table is neat and readable. Now let's talk about question 6. Why do we use set W when displaying the table? This is easy. Set W is used to ensure columns align neatly and to improve readability in tabular format. As for question 6b, what happens if a subject name is longer than the allocated width? Now, longer subject names may cause them to overflow into the next column. The solution is to increase set W and tourniquet names. Finally, let's move on to question 7. Question 7 is the last modification that we need to do to our program. The question asks us A. To accept dynamic number of subjects. For example, if the user wants 5 subjects, your program can accept 5 subjects. And if the user asks for 8 subjects, we need to accept 8 subjects, and so on. As for question 7b, we are asked to modify it to display total credit hours in the summary. And for question C is to add a minimum and maximum score achieved. We enhance the program to accept a dynamic number of subjects, display total credit hours, and show the minimum and maximum scores achieved. Here you can see all the codes that we have changed in the main source to cater to all of the needed modifications. Finally, we talk about the full demo of the program. Now, as this lab shape was done as a group, me and my group managed to code this fully, and here you can see the full code for this demo program. Here is the complete program in action. As you can see, we have shown you all the coding and the run process at itself, with 3 subjects that we have added for the run, which is computer programming, HVAC, and dynamics. The GPA was calculated and we got 3.90. This confirms that our program works correctly. To wrap it all up, in conclusion, this lab has helped me and my friends strengthen our skills in input validation, array manipulation, GPA calculation, and output formatting. It was a collaborative effort, but this presentation is obviously my effort. I am proud to present our group's work today. Thank you so much for your time, and I hope you enjoyed my presentation. I hope you understand coding a bit more better now. Thank you so much. This is Devendran Saegaran signing off.